Welcome to the next session on water technology. In this session, we will be dealing with treatment of sewage water and softening of water by ion exchange method. To begin with, first we'll see sources of water pollution. There are many sources of water pollution, but in general, two sources exist: direct source and indirect sources. First, we'll see direct source. Direct source means it includes effluent from industries, sewage from domestic usage, waste treatment plants, etc. These waste they will be directly discharged into water bodies such as rivers, lakes, etc. Okay. Even though it has been regulated in most places, some pollutants still get into these waters. Now, indirect sources include contaminants that enter the water supply from soil or underground water systems. That is, the pesticides, fertilizers, etc., used in agriculture, contaminants from automobile and industrial emissions. These contaminants they will be present in the atmosphere and they will enter groundwater through rainwater. Now, sewage treatment. Wastewater from industries, it is called as effluent. Whereas wastewater that comes out of domestic use, that is from your kitchen, laundry, bathrooms, etc., it is called sewage water. Sewage water, it will be rich in pathogenic microorganisms, it will have bad odor, etc. So, it is absolutely necessary to convert sewage water into environmentally safe water. And this is carried out in three stages: primary treatment, secondary treatment, and tertiary treatment. So, first we'll see primary treatment. Primary treatment means removal of suspended solids, oil, and grease. It is called primary treatment. Okay, it involves several steps. So, first step is screening. In this step, large suspended or floating matter that is present in the sewage, it is removed by making use of two mesh having different pore size, that is in the range 2 to 5 centimeters and 0.25 centimeters. So when the sewage water, when it is allowed to pass through this mesh, suspended particles or the floating matter which are in this size range, they will be removed, and the sewage water that comes out of the mesh, it will be free from these large suspended or floating matters in this size range. Now, second is silt and grit removal. In this process, the water after screening, it is passed through channels in a grit chamber slowly, so that silt and grit, that is sand, chips, coal particles, etc., present in sewage water, they can be removed. Next is sedimentation. So sewage water after screening and after silt and grit removal, it is subjected to sedimentation. That is, the suspended impurities present in the water, they are removed by the process of settling. That is, water is taken in a V-shaped vessel. This is a V-shaped vessel, and the sewage water, it is transferred into this V-shaped vessel, whereby due to gravity, the suspended particles, they will settle down and they can be removed. And fourth step is oil and grease removal. In this, air under high pressure is passed into sewage water containing oil and grease. As the solubility of air in water is low, excess air, it will comes out of water in the form of bubbles. And these bubbles, they carry oil and grease along with them to the top, and they can be removed by skimming. Now, secondary treatment. It is also called activated sludge process. This treatment is to remove biologically oxidizable impurities present in polluted water. Here, the wastewater sample after primary treatment, it is mixed with activated sludge under aerobic conditions. That means in presence of oxygen. So primary Water after primary treatment, it is mixed with activated sludge in presence of air. Activated sludge, it is nothing but water sample containing high concentration of microorganisms like Acinetobacter, Bacillus, etc. So, when the primary water after primary treatment, when it is mixed with activated sludge under aerobic condition, what happens is that the microorganisms that is present in the activated sludge, it will oxidize the biologically oxidizable impurities into carbon dioxide and water. Thus, all the biologically oxidizable impurities present in water, it can be removed by activated sludge process. This shows the diagrammatic representation of activated sludge process. So here, raw water after primary treatment, it is mixed with activated sludge and passed into an aeration tank where it gets mixed with sufficient air. So in presence of air, the microorganisms which are present in activated sludge, it will oxidize the biologically oxidizable impurities present in the sewage water to carbon dioxide and water. And water that is coming out, it is passed through a clarifier or settler, whereby the impurities or the excess activated sludge, it gets settled down, and the clear water, it is sent for tertiary treatment. The excess activated sludge, it is taken off. A part of activated sludge, it is sent for further treatment. Now, next is tertiary treatment. In this step, chemical impurities, bacteria, remaining suspended matter, and dissolved gases, they are removed from the sewage water. So tertiary treatment, it involves 5 steps. First is removal of chemical impurities, say removal of phosphates. If phosphate impurities, if it is present in sewage water, it can be removed by treating with lime. Lime is nothing but calcium hydroxide. So upon treatment with lime, this calcium, it will combine with phosphate ion and form calcium phosphate precipitate, and they can be removed. As it is insoluble, they can be removed. Thus, phosphates present in sewage water, it can be removed by treating with lime. Next is filtration, that is suspended impurities, fine suspended impurities present in the sewage water, it can be removed by filtering through sand bed or sand filters. Third step is sedimentation with coagulation. Here, coagulating agents like alum, ferrous sulfate, etc. are used. Alum, it is nothing but double sulfate of aluminium, and this is sulfate of iron. So either sulfate of aluminium or sulfate of iron is used as coagulant, and these coagulants, they will combine with water and form the gelatinous precipitate of their metal hydroxide. That is, if we are using sulfate of iron, it gets converted to the corresponding hydroxide, that is ferrous hydroxide. If aluminium sulfate is used, it will get converted to aluminium hydroxide. So the sulfates, they will get converted to a gelatinous precipitate of their metal hydroxide, and the fine particles of water, they will get adsorbed on the surface of the precipitate, and they will settle at the bottom of the sedimentation tank, and they can be removed. So this is how use of coagulating agents help in the removal of suspended particles. Now fourth step is degasification. Dissolved gases like ammonia, carbon dioxide, hydrogen sulfide, etc. it is present in the sewage water. And these gases, hydrogen sulfide, ammonia, etc. they will impart a bad odor to the sewage water. So to remove these waste gases, to remove these dissolved gases from wastewater, the water is passed through a degasifier. Degasifier, it is nothing, it is a large tower fitted with a number of perforated hot plates. That means plates with holes. So it is a degasifier is a large tower fitted with a number of perforated hot plates. Hot wastewater, it is made to trickle through these perforated plates. So what happens when the hot wastewater is made to pass through these perforated plates? The dissolved gases, it will come out from water in the form of steam. And thus the dissolved gases that can be expelled from water. Next is disinfection. So here, disinfection means to kill the microorganisms that is present in water. And chemicals which are used to kill or destroy the microorganisms, they are called disinfectants, and the process it is known as disinfection. Now, major disinfectant used it is chlorine gas. So chlorine gas, when it is passed through water, what happens? Chlorine gas react with water to form hypochlorous acid. Chlorine reacting with water to form hypochlorous acid, that is HOCl, along with hydrochloric acid. This hypochlorous acid, again it will decompose forming nascent oxygen and HCl. This hypochlorous acid as well as nascent oxygen, both are powerful germicides. That means they have the ability to kill the microorganisms. So this is the final step in tertiary treatment. So that these steps, that is primary, secondary and tertiary treatment, will help conversion of sewage water into environmentally safe water. Now next we come to softening of water by ion exchange process. We know hardness of water, it is due to the presence of salts of calcium and magnesium, that is bicarbonates of calcium and magnesium, chlorides and sulfates of calcium and magnesium. So if these salts are removed, then hard water, it can be changed to soft water. So the process of removing hardness causing ions such as calcium and magnesium ions from hard water is called softening of water, and softening of water is done by exchanging the ions causing hardness of water with desired ions from an ion exchange resin. So the ions which cause hardness of water, it will be replaced with ions from an ion exchange resin. So ion exchange resins, they are high molecular weight cross-linked polymers with a porous structure. So ion exchange resins, they are high molecular weight cross-linked polymers with a porous structure, and they have certain functional groups attached to the polymer chains, and these functional groups are responsible for ion exchange properties. Ion exchange resins, they are of two types: cation exchange resins and anion exchange resins. So cation exchange resin means resins that contain acidic groups and are capable of exchanging H plus ions with calcium or magnesium ions present in hard water. They are called cation exchange resin. An example for cation exchange resin is shown here. This cation exchange resin, it has the sulfonic acid group SO3H. So here, when the hard water is passed through this cation exchange resin, what happens is that the calcium and the magnesium ions present in hard water will replace this H plus ions. So this happens in cation exchange resin, whereas anion exchange resins are resins that contain basic groups, and they are capable of exchanging OH minus ions with the anions chloride, sulfate, bicarbonate that is present in hard water. So this is an example of anion exchange resin. This is a tertiary ammonium group. This is present. Okay, and in this tertiary ammonium group, you have a hydroxyl group attached to it. So when hard water, when it is passed through anion exchange resin, the anions present in hard water, that is chloride, sulfate, bicarbonate ions present in hard water, they will replace this OH minus ions present in the resin. So cation exchange resin means it is capable of replacing H plus ions with calcium or magnesium, whereas anion exchange resin means they are capable of exchanging OH minus ions from the resin with anions, chloride, sulfate or bicarbonate. Now let us see the process. Here, cation exchange resin and anion exchange resin, they are packed in separate columns. And hard water, that is to be softened. Hard water, it is passed to the cation exchange resin first. So at cation exchange resin, what happens? The H plus ions of the resin, it will be replaced by calcium ions and form R2Ca plus 2H plus. So H plus ions are replaced by calcium ions, or the H plus ions, they will be replaced by magnesium ions. Then it forms like Mg2 plus 2RH plus giving R2Mg plus 2H plus. So here when hard water, when it is passed through cation exchange resin, these cations, they will replace the H plus ions present in the resin. Now the hard water, after coming out of the cation exchange resin, it is then passed through anion exchange resin. So when it is passed through anion exchange resin, the OH minus ions that is present in the resin, it will be replaced by the anions present in hard water. Like chloride, sulfate, bicarbonate, etc. They will replace the OH minus ions of the resin with these anions. Now, the water that comes out, it will be free of both cations as well as anions, because H plus ions and the OH minus ions release, they will combine to form water molecule. So water that is coming out of the ion exchange process, it is free from ions, and therefore it is called deionized or demineralized water. It's called deionized or demineralized water as it is free from ions. Now next is regeneration. When the resins, when they are continuously used for the treatment of hard water, they will lose their capacity to exchange ions. So they should be regenerated. This process of regeneration, it is just the reversal of reaction that takes place during ion exchange. So cation exchange resin, they can be regenerated by passing a solution of dilute HCl or dilute H2SO4. By passing dilute acid to the cation exchange resin, cation exchange resin can be regenerated. How? Because now the cation exchange resin, the H plus ions will be replaced by calcium or magnesium ions. So when you add acid, what happens? Dilute acid, when you add to the cation exchange resin, the Ca2 plus ions, calcium as well as the magnesium ions, they will be replaced by H plus ions. And thus the exchange capacity of the resin can be regenerated. Similarly, in case of anion exchange resin, the exchange capacity, they can be regenerated by passing solution of ammonium hydroxide or sodium hydroxide. So when ammonium hydroxide or sodium hydroxide, when it is passed through the anion exchange resin, the chloride ions that are present in the resin, they will be replaced by OH minus ions as given by this equation. Thank you.